Now, moving on to our next speaker, Tanya Dixit, a generative AI solution architect at Google, where she drives AI innovation and strategic programs using tools like Vertex AI and Kubeflow. Before joining Google, Tanya led machine learning initiatives at Crayon, focusing on MOPs and multi-cloud platforms such as AWS and Azure. She served as editor-in-chief of the Future Stack, Canberra's first AI newsletter shaping through leadership in AI space. Her work spanned industries from developing AI solutions for bushfire risk analysis to working on quantum decoders, and she holds a master's in machine learning from ANU. In her talk, Agentic AI, What Works and What Does Not in Production, Tanya will share honest insight on the realities of deploying AI agents at scale, what delivers real value, what to avoid, and lessons learned from production use cases. Please join me in welcoming Tanya Dixit.
Thank you for that great introduction. Hey everyone, hope you can hear me. Awesome. So let me see if I can get my slides up there. But yeah, today I'm going to be talking about what are some of the lessons I've learned productionizing AI agents. I'm going to be focusing on GCP, Google Cloud, because that's what I've used in most of my projects. And then we'll be talking about, what are some of the lessons learned, what are some of the best practices, what are some pitfalls to avoid, and then we'll just move on to questions. So before I start, I just want to discuss this a little bit. What does it mean to be agentic? Like, what is an agent? So there are many different definitions out there. From what I see, it's basically a while loop, which can be a more sophisticated orchestrator as well, which has an exit condition, right? And you're giving the ability to make decisions. You're giving the ability to act. You're also giving the ability to think and reason. And based on thinking and reasoning, the autonomy to decide when to do what. So basically, there's an element of autonomy here, which is different, which is what differentiates agentic applications from non-agentic ones. And then the tool calling criteria is the thing we call action, right? So you're either getting some data or you're changing something. So that's how loosely agentic is defined. I've seen agents being used for multiple purposes. But then the first question I generally ask when someone comes to me and say, OK, we want to develop an agent, like, why do you want an agent? Would this application actually need an agent? Or could you actually do with a workflow or just a simple script that brings a bunch of functions together or brings a bunch of, it could be just a DAG, right? So these are some of the questions we generally ask. And the answer is most of the times you don't need an agent. But when you do need that ability to either get a lot of context in or to maybe have some long-running operations or maybe decide on the go what you want to do, then you probably would, you probably end up developing an agent. OK, so when we talk about putting agents in production, what's needed? So I've kind of highlighted the agent part of it is very small. The rest of it is pure old software engineering, like really good software engineering. And if you look at this part, which is the agent ops part, I don't know if you can see the pointer. I'm not sure. But anyway, so there's the agent ops part, which talks about evaluation, monitoring, CI/CD. There's also a CT part, which is the continuous training part. So continuously making your agent better. And then prompt management. These are very important parts of your agent because a lot of our agents that we're developing, prompts are really important parts of it. And you change something in the prompt, it completely changes the behavior. I've seen that happen, and it's super sensitive to the prompt. So it's really important for us to version those prompts. So that's why prompt management comes in. And I'm emphasizing that because it's very different to software engineering, where we don't really have something like prompt management. We have code versioning, but we don't have like prompt versioning or even data versioning or model versioning. So these are the parts that we sort of bring in or talk about when we talk about agent ops. Then the peripheral parts, but really important ones, are data and tools, the UX of the agent, which is absolutely important. And right now we have seen agents mostly as chat assistants or chat support, but there are a lot more ways you can actually develop an agent and make it available to your users. And then controls or guardrails, which we'll touch upon a little bit. But today's focus is mostly going to be on evaluation, monitoring, a little bit of CI/CD, and we'll be talking about tools registry a little bit. So the way I actually want to talk about this is, okay, like from my experience, what I've learned in building an agent. So we'll think about, okay, let's build an agent together. I'll talk about repo setup, not so much as designing that system, because you've read articles from Anthropic about what are the different agentic patterns. So I'm not going to talk about that today. Touch a little bit on CI/CD setup, tool registries, and then the main part, which is evaluation, monitoring, and guardrails. Okay, so repo setup. So this is a sample repository setup. It has a lot because I just tried to cover everything. But I've highlighted 3 main parts of it. And this is every framework that you use, whether you use Google ADK or you use LangGraph or you end up using Pydantic or I think there's a new one from AWS called Strands. They will probably have different repo structures, but something on the lines of this, right? So if you look at the agents part, so generally you would have a root agent or an orchestrator agent, and then you'd probably have like sub-agents if you're going for a multi-agent system. The tools part of it is interesting because how do you structure your tools? Like if there's a big organization that we're talking about, right, and if this agent spans multiple verticals of that organization, it can become really difficult to handle tools. So ideally you would have a tool registry where like all of your verticals are following some sort of standards and registering your tools there. So you can have tools that are very specific to your sub-agents, or you'd probably have tools that all of your agents utilize. So you can just structure that accordingly. And then evaluation is like super important. So when we talk about Google ADK has it has inbuilt scripts that you can use for evaluation, and you can structure your eval set accordingly. Okay, moving on to tools. So the tools that you'd be using would be data as tools. So you are either fetching data or you're updating some data, right? You'll also be using other agents as tools. So that's like another tool that your agent might be using. You'd be using standard APIs as tools, like the APIs that your organization has already developed. Your agents would definitely be using those. And you'd probably end up using some code repositories as tools if you're working with agents that are utilizing your code repositories and building on top of that. So code generation agents, for example, you might be using Gemini CLI or Claude Code or some of them, like the many code generation agents that have popped up. So the recommendation here is to have a global tool registry, but have a standard so that all of these tools can be developed in silos, but they have a standard way of getting registered in your organization, and everyone like developing agents across your organization can utilize them. Okay, now this architecture is from one of the open source repos in Google Cloud Platform. It's called the Agent Starter Pack with a hyphen in between. So this gives you the high-level architecture of building and deploying an agent. So let's unpack this a little bit. So let's look at the LLM orchestration part, which has the agent orchestration. So if you end up using Google ADK, you can actually utilize any of the models, but let's say you don't end up using ADK. So agent orchestration part is like whichever agentic framework you end up using. Then let's look at the evaluation part, which is like if you're using GCP, then I would highly recommend using the Vertex AI eval service. And if like I would highly recommend going to the Agent Starter Pack and looking at like different components of it. LLMs will touch a little bit going forward. And yeah, some ideas there where LLMs are moving towards. Then data, again, just depending on what your current data looks like. Actually, let me just go to the next one. So yeah, let's talk about evaluation first, because we'll cover each of them one by one. Okay, so evaluation. I think one of the most important parts of developing an agent is knowing the success criteria. Like, okay, once I develop this agent, what does good look like? Because agentic systems are, like, it's almost like you're pushing the inference time compute to just like the nth level. You're actually doing a lot of compute on the inference, and there's a lot of uncertainty there, and that's why the evaluation becomes even more important. So we kind of break evaluation into smaller steps. So the first part of the evaluation is, so if you look at step 1, conduct all the single turn evaluation steps. This does include making sure your tools, like you've written all the unit tests for your tools, so your tools are giving all the right outputs based on your input, right? Then it also kind of includes that when you either like execute the agent in one turn, you're like it's giving you the right output. So that's just like a very small part of it. But the complexity comes in when your agent is making multiple tool calls, or even like transferring to some of its sub-agents and then making those decisions. So here, we need to evaluate not just the steps that it's taking. So the step could be transfer to an agent and then calling a tool, or then call a tool or transfer to an agent. Like all of these different permutations and combinations, those are important. And it also depends on your specific use case. You might just be concerned about the tool calls and not really worry about the sub-agents, because the sub-agents are just all doing their thing, and maybe your application doesn't really sort of concern with that. Or maybe the order doesn't matter for you. Whatever order the agent is calling the tools in, you're just concerned with the final output. But in most cases, the order will matter, the number of tool calls that you're making. You would probably want to make all the tool calls that are in your golden trajectories, and probably like not miss any of those. So those are important. And also the reasoning is also important. So let's say your agent is making the right tool calls, but it's doing that with wrong reasoning. Like it's made like tool call 1, 2, 3, which was your golden trajectory, but the reasons were completely off. So you would want to have a look at that as well. Like, what is in my prompt that's causing my agent to do this? And for the reasoning step, generally you would use an LLM-based eval. So you basically use LLM as a judge to evaluate that. And then the final response. So your final response could be very, like, it depends. Like if it's a text, then you would probably use LLM as a judge as an eval, and then create some specific eval metrics for that, like correctness or comprehensiveness. So these are some of the metrics that we've used for some of the agents. The other interesting bit here is when you look at step 4, which is the evaluate memory. So this is interesting. We'll be discussing a little bit on memory. A lot of the agents people want to develop are personalized agents. So they're personalized to the user. So what does memory help you do? Let's discuss a little bit about memory here. You have short-term memory, which is the in-session memory. Whatever the user is talking about in the current session, the LLM needs to know that, or the agent needs to know that and make decisions based on that. So that's like the short-term one. Then you have the long-term memory, which is based on the user's interaction, like multiple interactions throughout days or weeks or months. The agent retains some of the knowledge about the user, like some of the bits of information that it retains. And that's the memory that helps you personalize your agent. And while you're evaluating your agents, if personalization is important, and if the decisions are made based on that information, you also want to evaluate the memory, the retrieval process of the memory, and the interpretation of the memory. So are the correct facts being retrieved based on the query? So actually, there'll be 3 parts there. There'll be the query part, like is the query correct? Like is my system, whatever retrieval system I've spun up or I'm using, is that giving the right query to my memory system? Is the right memory being retrieved? And then, is that being correctly interpreted to give the right answer? So that's like another layer of evaluation in memory. Okay, so moving forward, let's talk about LLMs here. So it's very straightforward right now because I think there are like two groups of people. Some people see LLMs as commoditized. Some people see the nuances. I think right now, we're not at that level where LLMs are commoditized. For example, Gemini is like really good at summaries and like summarizing information. I think Claude is really good at tool calls. So there are some differences between LLMs, like these subtle differences. And I think that's where we're going towards as a community. We're probably going to have to develop LLMs that are good at specific tasks, not just in domains, but like at specific tasks, like LLMs that are good at giving us more deterministic responses. So every input I give needs to be, the output needs to be same. I don't need that LLM when I'm asking it to create jokes or like summaries, but I probably need that LLM when I'm asking it to maybe work, like integrate it as part of a spaceship or something, right? Like we kind of need to have different architectures based on what's the strength of the LLM I'm utilizing. Right now, most of these LLMs are like pretty generic. Like it's up to us to keep testing them. But I think that's where the research is going to evolve. And yeah, like I think that'll also have a really big impact in how we design agents. Because the orchestrator agent, we might need it to be more like less deterministic. We might need it to have better thinking, for example. So all of these different nuances also decide what kind of agent, like how you design your agentic system. Okay, let's talk about observability a little bit. So when you use Google ADK, there is built-in observability. So like if you're using Agent Engine to deploy, you can utilize the built-in tracing, as well as you can utilize cloud logging, cloud tracing. You can all utilize that. But the screenshot here is from Agent Ops, it's a third-party service which allows you to look at all of these interesting bits of information for your agentic system, just using like 2-3 lines of code. There's this one, I've also used OPIC. So what it's essentially doing is you can look at the latency of your system. You can look at the latency of individual LLM, sub-agent calls. You can look at the latency of the tool calls and like trace the entire trajectory of the LLM as well, of the agent as well. You can also look at the cost as well as tokens utilized. So this gives you a very good overview of how the system is performing, and I would highly, highly recommend using it. So basically, we used OPIC in one of our projects, and yeah, it was pretty good and gave us a very good overview of how the agent is working. Okay, let's talk about deployment. So there are two options for deployment. There's Cloud Run, which you can just package up your agent and deploy there. And there's Vertex AI Agent Engine. So a few months back, I would have recommended Cloud Run. But now I think Vertex AI Agent Engine is a very good choice. And the reason is, so Cloud Run is just a very small part of what Agent Engine offers. So Agent Engine is a wrapper around Cloud Run, but it also allows you to do all of these things built in. So it's a fully managed runtime. So you don't have to lift a finger. You can just, like basically just 1 or 2 lines of code and you're able to deploy immediately to Agent Engine. Yeah, so all of these things mentioned here, it's fully managed, scales up and down based on your needs, built-in security authentication. Also, it's actually framework agnostic, so you don't have to develop using ADK. You can use LangGraph or others, Crew AI, yeah. The other thing that Agent Engine does is it has built-in memory bank as well as example store. I'll be talking about memory bank a little bit today, but basically what it allows you to do is, so you can plug in your agent and have a memory, so like have memory out of the box, so you don't have to worry about it, right? So any user that uses your agent will be able to store information, like you'll be able to store information and retrieve using that memory bank. The example store is also pretty interesting because it's going to retrieve like It's basically in-context learning for that agent based on the relevant examples that it has seen before. And for this, you would probably have to spin up a database, right? Before, you would probably have to do, can't remember, yeah, vertex store. You would have to spin that up and then create a RAG pipeline, basically, right? But you don't need to do that anymore. You can just use Vertex Agent Engine. Yeah, so, and it has built-in monitoring, tracing, logging, so, which is great. Cool. So this is how you actually deploy using Agent Engine. So you just define your agent, and then you say that, OK, create my Agent Engine instance, and then you can start querying it, and yeah, you can just manage all of your Agent Engine instances. So it's pretty straightforward to get started with. And it also has integration with Agent Space. So if you're able to deploy an agent to Agent Engine, you can easily get it as part of your Agent Space. So if your organization is using Agent Space, you can use your, you can actually make your agent available to anyone in your organization using Agent Space, which is pretty cool, right? Like if you're developing something and your teammate is able to use it instantly, it's, yeah, and it's actually pretty straightforward. Like it's one script and done. People can use it. Okay, let's talk about memory bank now. So this is, it's one of the most interesting parts of Agent Engine. So most of the memory, like most of the problems that we get with memory are, like imagine you're building a system, right? And you want to understand what's important, what should I store about the user, and what should I not store. It's a pretty difficult problem to solve because you're storing all of the conversations. Like ideally, you'd be storing whatever conversations you've had with the user in a database, right? And you'd be either running a script to extract the correct information, and then you'd have to create a RAG on top of that to retrieve all that information in real time. And it's not an easy thing to build. So this paper, so this image is actually from a paper. It's called Reflective Memory Management. It's from Cloud AI, Google Cloud AI Research, and a few others. And what it talks about is reflective memory management, which is two things together. It basically, what it does is, it decides what to store in memory based on what could be important in the future for the user. So that's like one way it stores memories. The way it ranks memories in times of, like at the time of retrieval is, so let's say I asked a question, and there was a retrieval, and some of these memories were retrieved, and some of them were, some of them were used, and some of them were not used. So the ones that were used are ranked higher. So it's basically a learning, it's a reinforcement learning algorithm that sits on top of this. So that's the ranker that they, re-ranker that they use. Yeah, so this is part of the Vertex AI Agent Engine, which is the memory bank. Okay, so I think we've discussed a lot. I've given you a lot to think about. I just want to summarize all of this in the last 3 slides, which is like, okay, what are some of the good practices while you're developing agents? Like we all know the good software practices, so I want to focus on like some of the design and the thinking practices. I think experimentation has been really important in developing our agents, right? Like some of the best agentic systems like Deep Research and co-scientists, they've shown me like you probably need constant literature review, and you want to run your development in a hypothesis-driven way. So you would probably want to hypothesize, then verify that your hypothesis is correct or not, and then include that as part of your system or not, right? Like that's like one way. Then invest in robust tooling. So yeah, like definitely make sure you think about evaluation properly, have a really good logging, tracing, debugging hygiene, and yeah, experiment a lot, and prioritize reasoning and context engineering. That's like super important. So that's where the evaluation also comes in. Like when you set up your evaluation to evaluate reasoning as well as memory, that takes care of a lot of this context engineering, as well as reasoning issues that we see a lot in production. Then, yeah, start focused and iterate. That's very important. So, like for the projects that I did, we started very small and then we kind of sort of built on it, and the architecture evolved as we went through that. And I think in the future, we're definitely going to see more sophisticated agents that can run for longer, can be more specialized and can collaborate. Like, for example, deep research is a good example of it. Replit just announced, I think, Agent 3. It has 200 minutes of running time, so that's, yeah, pretty cool. Then these are some of the agent ops practices. We've discussed that. If you want to go ahead and take a screenshot, please go ahead with this. I'm not going to talk about it again. We've already talked about it. And then what are some of the bad practices? I think one of the worst practices is using agents for the sake of using agents. I've seen a lot of people do that. Don't do that. It's, yeah, it just ends badly. Unclear success criteria, that's a bad practice in all ML projects, not just agents, but more so for agents because you don't know what's happening and then you don't even know how to evaluate it. Then unclear business use case and value proposition. So I think that ties back nicely to the first one that, oh, we're using something cool called agents. I think there needs to be a clear value proposition and it needs to add value. Otherwise, developing agents is not recommended because it takes a lot to maintain them, to evaluate them, and to expand them. Like there's a lot of power there, don't get me wrong. But then it also needs a lot of good engineering. No clear roadmap of maintaining agents, like again, ties back to my previous point. And there's some really good governance also required for an agentic, like for these agentic use cases to be rolled out for huge enterprises and to be like actually useful for the company. All right, so that's me. Thank you. And please, any questions, let me know.
Wow, that was so much of information for me personally because I'm a social work student. So I was like, okay, so much thing going on here. Thank you so much, Tanya. It was fabulous. I'm sure everybody was taking notes and I saw them enjoying your session a lot. So I'm sure we have some curiosity out there. So let's look into that. We have one question already. So anybody could help us with the mic there?
Hi,
Hey.
myself Gopinath. Currently, I'm working on ADK. I'm building a multi-agent system. So currently what I'm facing is, for example, I'm building a root agent. I give 2.5 Pro because it is doing all the heavy lifting. And I have sub-agents, and I give 2.0 Flash. If I change the model from 2.0 Flash to 2.5, I can see major difference in my output.
Yeah.
How can we solve that?
You don't, you just use 2.5. Why do you want to?
No, because I'm experimenting
Okay.
because my use case is like extracting some documents and then transforming into another format.
Okay.
That is my use case.
Yeah.
So every time if I change the model, it is showing different output. In case if we are evolving, the models are getting mature.
Yeah.
If, for example, if we get 3.0, then if I fit into that, again the output will change, right? How can we
Yes,
solve
absolutely.
Yeah.
So that's why you actually think about evaluation and benchmarking. So I would highly recommend having an eval set of just like even 5 to 10 use cases. So your use case is around document extraction, is it? Okay, so what's the input and what's the output? Is it like PDF?
For example, if I'm extracting the meeting notes,
Yeah.
I'm converting into an BRD document or Confluence page or
Okay.
user story, something like that.
Okay, and can you define success in this use case? For example, like, should the documentation be, I guess it should be correct, it should be succinct, right? Like, it should be concise, it should cover everything, it should be comprehensive, right?
For example, if there is a meeting discussion, I extract the meeting notes out of it, and I want to convert into a BRD document.
Okay.
So I have a BRD template. I want
Yeah.
to fit in these meeting notes into a BRD document.
Yeah.
Whenever I change the model, sometimes those template is not able to filled by the model.
So is it that you're getting better results with 2.5 and 2.0
Yeah.
is not good
Yeah.
at all?
Yeah.
Okay, so I would suggest, so 2.0 is a good baseline for you, right? Now you need to distinguish between like, okay, when I use 2.5, what are some of the differences? There's a template adherence difference, right?
Yeah.
So template adherence, you can actually use another LLM as a judge to see which model is doing better. So just have a benchmark. So whenever you change the model, run through that five or six use cases. You can have LLM as a judge, and that LLM can be the best one you can find, right? Because you're evaluating, you're running it offline. You don't really care about latency, and it's just 5 cases, so you don't care about cost, right? And then you decide whether or not you actually want to change that LLM in production when you productionize it. So that's when you make that decision.
Because currently what I'm doing is, currently I'm making it deterministic using my prompts. I give few shots to act like, okay, this is how you need to extract and transform it.
Right.
For example, if we go further, if Gemini is getting mature, we come Gemini 3.0, 3.5.
Yeah.
I want to make sure that output and extraction transformation should be in the similar way.
Yeah, yeah.
But it is not doing.
Yeah, I think that could work. Like that's what you're looking for, right? Template adherence. Yeah.
Okay, thank you.
Any other questions? There. At the back.
Hi, Tanya. I'm Abhinav Jain. So I work extensively on the Google AD side. So I'm working on a multi-agent RAG application with access control. So my question to you is regarding agent ops. So in the documentations, there are multiple tools similar to agent ops.
Yeah.
So is the agent ops the recommended way, according to you?
So I've used OPIC a lot. I actually really liked the experience of it. Agent ops is something a bit newer. I think it's up to you what you want to use. I don't have any recommendations as such. I would actually recommend OPIC, but Agent Ops has a nicer interface. So yeah, I think.
And are these tools these are third-party tools, or
yes.
they are?
Yeah, these are third-party. OPIC is a third-party tool. Agent Ops is, and then I think they're also looking at Langsmith, because Langsmith is the choice of observability for people who are developing with LangGraph. So yeah, but I'm not sure, but I think that's gonna happen as well. Also, weights and biases. Weights and biases is something I've used a lot for, because it integrates really well with ML flow, and like while you're developing the ML pipelines, you can actually log your metrics and everything there. So yeah, if you had to use something that you already use, I would highly recommend weights and biases. Yeah, but I haven't used it for Agent Ops specifically.
But, is there anything in the Google Cloud space like GCP that we can use?
Yes, so Agent Engine also has its own, the dashboard. So when you go to console and you type Agent Engine, you'll actually see a dashboard. So it has tracing, it has logging. So the same tracing that I showed you through Agent Ops, you can actually use Agent Engine for that as well. There are a few differences between Agent Ops and the Agent Engine dashboard. So that's one of the reasons Agent Ops is more like recommended. But yeah, like depending on how much information you need, I would, because Agent Engines is something that already comes in. So you could try that if that's enough. Yeah, you could definitely go with Agent Engine.
Can we see the conversations as well in that?
No, I think you only see the traces and the latency, as well as the it's latency, tokens, and trace, like the time per agent. Yeah.
I have a couple of more questions, but I will probably connect you after this event.
Awesome.
Thank you.
Thanks.
Thank you. Any more questions? We have one more here.
Hi. I'm trying to use AI agent to replace some kind of manual review for images. So my design is that I I have a agent and I ingest a lot of prompt with a lot of criteria to define a picture which is good. For example, like it should not contain watermark or some trademark, something like that. But the problem is that though the context window of the Gemini's model is huge, then if I define a lot of problems like that, the model started to collapse and the performance, is not as well as if I break down into their different agent that specialize in their domain. For example, an agent only detect some kind of this trademark or kind of other object. So, but the problem is that if I break down into different agents, I have to have a lot of like API calls.
Yeah.
And at that time, the cost is huge. But after evaluation, we realized that the result is better. So I just cannot think of any like a balanced design or some solution for this case.
Yeah. How many criteria are you putting in one prompt? The first design with just one agent or one call?
It's range from 3 to 4 different problems. I mean, for example, one agent may detect trademark, for example, like a logo, Apple logo, or Spider-Man, something like that. The second one is like detect the credit or personal information, something like that, which should not be,
Right. Yeah. And is it, so you're doing this for image, not videos, right?
Yeah.
So why don't you use some of the intelligence APIs, like image intelligence? So you can do brand detection, for example, like do object detection, take the outputs of that and try and see if that can offset some of your calls?
You mean use the traditional object detection?
Yeah,
models?
like traditional, kind of combine both of these, right? Traditional, get some more information, get some annotations, because that's going to be like super cheap for you to do.
Yeah, it's cheap, but for example, the problem is abstract. For example, like trademark. If you want to define what is the trademark, then the object must be like 100. It's 100 class or something. But with the VLM or Gemini models, with the range of knowledge is super broad, then it can define and it's better. So we are switching into that.
Okay, I see. Yeah, I think have to think about if there's any other way. But right now, I can only think if you can somehow use object detection. But yeah, you're right. Like then we'll have to define all of these different classes, and we don't want to do that. Yeah, that's a good problem. Let's connect after this.
Thank you so much. Do we want to take some more questions, or are we good to go for the day? One more, okay.
Thanks. So earlier in your presentation, you mentioned, different LLM models trying to train their models to be good at one specific area.
This is my hypothesis. This is like my research hypothesis that I recently formed in the last 1 or 2 days. I think that's where we should be moving. And like some of these models you can see, right? Like some of these are good at function calling or computer use. Some of them are better at code generation. You also have like code-specific models. You also have, like image-specific models that do have that capability. So yeah.
Yeah, my question is like, on the other hand, there's also development in the AGI side. So yeah, where do you see the state of the art for the AGI now?
I'm not developing or working on AGI, nor do I have interest in, to be honest, right now. But I think it's very difficult to define AGI. Like generally what I see AGI as being defined is anything that's going to be better than humans at everything, right? So that's general intelligence. So if you ask it to be a lawyer, it's going to be better than the best lawyer in the world, but it's also going to be better than the best doctor in the world. I think right now, I don't think that's happening or that's even possible from the architectures that we have. Like even if you think about the scaling laws, right? You think about, you scale the data a lot and you're scaling the models. Like I think we're kind of going towards a world where we're hitting some of these limits of the data as well as the compute. More so data limits. From my perspective, we would need some different paradigms and some different architectures to reach AGI. We will probably end up with specialized models and specialized agents. And then the collective of these specialized agents will be AGI because they're so connected. Like humans are, we don't live in like a connected like an interconnected web, right? Our brains are very separate. The consciousness of agents will probably be AGI, or the consciousness of LLMs or whatever, right? Or just, let's say, models. I think that's what AGI could look like. But one single model or one single whatever, doing everything, I don't think that's where we're going. Yeah.
All right. Thank you so much for your wonderful, inspiring talk. We have a small token of love for you.
Oh. Thank you. Thanks.
And of course, thank you so much, Faria and Tanya, for your amazing talk, inspiring all of us and building that curiosity among each one of us to do much better and think a little more differently.